702. The Naked Scientist.
Time for the Naked Scientist. We are with Dr. Chris Smith. Happy Monday. I'm going to jump into the very first question I have for you, which is the science of the midlife crisis.
Well, happy Monday for you as well, and happy Advent as well, because we're sort of just downstream of Advent Day, aren't we? I think it's a range of factors here, and people begin to look at their life and they begin to look at where they are in their life course, and they think how old they are in relation to how long they think, based on family history, lifestyle, other factors that may have already had a bearing in their life, how long they're likely to live, and therefore how long they have left. And for many of us in the first parts of our lives, we all fall into the trap of thinking we're going to live forever. And the rest of your life seems a long way off. And time goes faster, as we all know. If you're a little bit older, the faster it goes, the faster it grows. And you go through life with the minutes sometimes drag, but the weeks race by. And you suddenly realise 2 decades have gone, and if I want to achieve this, that or the other, I don't have as much time as I thought I did left to do it. You also have less energy because as you get older, your body claps out a bit. Sorry, I'm not selling this very well, am I? But that's the reality. We all age, and this means that our energy levels and our abilities do change. Your eyesight goes a bit, various things. And this has the effect of sometimes making people think, I'm not going to be here forever. I'm not going to be able to do all these things forever. I am only on this planet once, at least in this form, and therefore I am going to make some changes while I still can. And it's the catalyst, I think, that makes some people just get out of their armchair and make changes that perhaps needed to happen, but sometimes they make bad judgments and sometimes they make changes that they regret later. And I think that's why it's called a midlife crisis. For me, this summer I had a midlife crisis with my wife because we celebrated our 20th wedding anniversary. So we thought we're 20 years in and we're halfway through a medical career, so we'll have a midlife crisis. and recognise the fact that it was also her 50th birthday party. I'm not quite there yet. But yes, I think that probably sums it up, doesn't it?
Well, congratulations. That is absolutely amazing. All right, conversation for another day. Our very first question is coming through on the WhatsApp line that says, "Good day, Relebogile and Dr. Chris Smith. Please clarify if there is any danger or damage or harm to the fridge if I store stainless steel pots like AMC or Hart, I'm assuming those are the brands, inside in order to preserve food. I get lambasted each time I do it. Thank you." This is from Johnny, and I'm worried, Dr. Chris, you are going to be settling a long argument in somebody's marriage here.
Yeah, there could be another midlife crisis on the way, couldn't there? I think the answer is that you're not doing any harm other than taking up space. Stainless steel won't go rusty because it's stainless steel. And if it's got food in it, why dirty another thing, which by dispensing the food from the stainless steel into the other thing and then putting that thing into the fridge, you've got more chance to contaminate the food. It'll be at a high temperature for longer because the thing won't be at fridge temperature. So why not just put the pan in the fridge? Unless, of course, the problem is it takes up a lot of space with the handle and so on. It's not going to damage your fridge. The way a fridge works is it is basically pumping heat from inside the fridge to the room, leaving less energy in the fridge space, so the temperature is lower on the average energy of the things in the fridge. So anything you put in there donates its energy to the environment inside the fridge. The fridge then chucks that energy out into the room. So you're just making your fridge work a little bit harder to lower the temperature of whatever you put in there. If you just put the food and it wasn't in anything, then you're not having to take energy away from the thing it's in as well as from the food. But on the whole, taking that to one side, you're not doing the fridge any harm. It might be causing friction in your relationship by the sound of it, but it is not doing anyone any harm in the long run, either from a health or physical point of view.
So, Johnny, the reason you take the food out the pot and put it into containers is not because it's going to harm the pot or the fridge. It's because she said so. That's why you are doing it. Thank you so much for that question. Another one says, please greet and ask the doctor to explain the phenomenon of hibernation. Now that it's summer, flies and mosquitoes are competing to interfere with our lives. Where have they been before summer?
Right. Well, hibernation means different things to different creatures. But hiberno in Latin means I spend the winter. And hence hibernate is where we get that word which means spend the winter, and we tend to refer to a state of dormancy or being inactive, or in some animals' cases, being asleep. Now, some animals do literally go to sleep and they stay asleep for an entire winter. And some bears, for example, in frozen parts of the north, will go to sleep and they won't get up again for months. And they slow their metabolism right down. They reduce their body temperature right down. And they do this via running various clever genetic programs that means that they can basically protect their tissues from the harm caused by having a really low heartbeat, really low respiratory rate, and really low temperature. What we don't know is what the triggers are that turn this process on and off. There are some genes, there's one called HIT, or a hibernation-inducing trigger. People have found various things that switch on and switch off, probably by integrating signals from the environment, changing day length, average changing temperatures, food availability and so on, that tell an animal's physiology it's getting towards that time when you go to sleep. But we don't know exactly how they do it, but we do know that it does work, and people are really interested in studying this because it might be a way in which we can make people healthier, for example, because if people have to have operations or spend time unconscious or even go on long space journeys in the future, putting people into a state of suspended animation or hibernation at low temperature, it's a really potentially way of saving many, many lived years, as it were. Basically, it is a real thing. Animals do it. We don't do it. And if we get made too cold, except under very specific circumstances, it would be very deleterious to us. But the animals that are specialised for doing this do it very well, and they do it successfully, and it basically means they get through the winter with minimum demands for food, minimum demands for water, when food and water might well be in short supply, and it means they can retreat away and remain safe and ensconced in a winter nest until the average temperature comes up again, and that sends a wake-up signal, and they come back to life.
Thank you so much for that question. Here is a voice note.
Hi, Dr. Chris. I'd like to find out, there's many things that you can make food from. Are you able to make food, soil? Are you able to eat soil and get nutrients from that?
Hello, mate. Well, the bottom line is that soil is minerals and organic matter. And in the organic matter, there are lots of microbes. So in some respects, you are able to eat soil in the sense that when you dig into a jar of some kind of yeast spread like Marmite and things like that, these are made using soil-dwelling microorganisms, fungi. So in those respects, you are eating one component of soil. But what makes soil magical is that it can sustain plant life, and plants are nature's best solar panel. And plants have the biochemistry and the chemical know-how to collect energy from the sun, carbon from the air, nutrients from the soil and other minerals, combine them all together and make all of the important foodstuffs that we need and other animals that we rely on need. So you can't eat soil directly, but you are effectively relying on soil to eat. But I certainly wouldn't go and grab a mouthful of the dirt in the street because it's full of microbes and there might be some bad ones in there that won't do you any good.
Thank you so much for that question that has come through. Another one says, the naked scientist, am I correct to assume that the sun and the moon change positions, especially in winter, as in moon in the south and vice versa in summer? This is from Franz.
Hello, Franz. Well, they're two independent, totally different entities, of course. The sun sits at the centre of our solar system, and although the sun is turning on its own axis and spinning round, relative to us, the sun stays in the centre of the solar system, and the clutch of planets in our solar system are on big journeys or orbits, which are almost circular, bit of a squashed circle, but they're going round in a giant circle. And in the case of our planet, the Earth, it takes 1 year, 365 days, to complete that lap of the solar system. The moon is a bit like the Earth in relation to the sun. It is in orbit around the Earth, and it's going around taking not 1 year, but 1 month to complete each orbit of the Earth. The moon is not making a perfect sort of, it's not directly around the waist of the Earth, and because the Earth is a ball and the land masses curve round with the surface of the Earth, it's going to make it look like the moon is taking a curved path across the sky, but that's because of our viewing point of the moon. And of course the Earth is also tilted on its own axis at 23.5 degrees, which is why we have seasons, and this is why the sun relative to the horizon is higher in summer and lower in winter, because when the Earth is in that part of its orbit where it's tilted towards the sun, it's seeing the sun at a slightly different angle than when we're tilted away from the sun in winter. So the relative positions and therefore the length of the day changes according to whether it's winter or summer.
Thank you so much for that question. Azamo asks, Doctor, why do our mouths generate saliva if we smell bad or disgusting smell or nice food smell?
This is part of a neurological reflex, a bit like the sort of oral equivalent of a knee-jerk reflex. When you tap on the tendon of your knee, either with your fingers or the doctor might do it with a hammer and make your foot kick out, when you put a smell up your nose, then it triggers through the brainstem the production of signals in that part of the nervous system that make you make saliva, because in the case of nice smells, the anticipation is, I'm going to eat something. And the role of saliva is to lubricate your mouth, to dissolve some of the food constituents directly, to contribute enzymes for digestion starting in your mouth, and therefore to help you in the eating process. And when we feel there's something horrible which is going to make us throw up, we also make lots of saliva to help the reverse process be a bit more pleasant and a bit less painful. So in either case, it is a neurological reflex where you stimulate the production of saliva to help with what's going downwards or upwards.
Thank you so much for that question. Another one asks, why do siblings of the exact same parents look different if it's the same genes?
Well, you share as a child 50% of your genes with each of your parents. So mum has 2 sets of chromosomes, half she got from her mum and half she got from her dad. And dad has 2 sets of chromosomes of each of the chromosomes, half of which he got from his dad, half of which he got from his mum. When dad makes sperm, he doesn't put all of his genes into his sperm. He picks, as in nature picks, a random selection of each of the pairs of chromosomes. So one of the number 1 chromosomes, one of the number 2, either the one from the mum or the dad, right the way down the list, and puts that unique combination into the sperm. And the mum does the same thing, making the egg. So when you bring them together, you end up with the right number of chromosomes, but you've only got half of each of the genetic material that was in each of the parents. So therefore, when that process happens to make the next set of sperms, because it's a random selection of which of the sets of chromosomes you're using, and there are additional things that happen called crossing over when you make the sperms and eggs, where you swap bits of genetic material between the pairs of chromosomes, so that adds extra diversity in there. So there is no match unless they are an identical pair of twins.
Thank you so much. Doctor, an interesting one I'm going to take here that is asking, how do you know all of this knowledge?
Well, the answer is that over the last 20 years or so, since we started doing The Naked Scientist, in fact, it's 22 years now, I calculated the other day, I've probably interviewed between 5,000 and 6,000 scientists around the world. And these are people who are some of the brightest people who are the best in their particular field in science. And they've given me half an hour, sometimes an hour of their time to explain what they've been working on, why it matters, and what they've discovered about it. So effectively, I've had thousands and thousands of educational sessions with some of the best scientists, and some of it's rubbed off. So I'm able to remember a bit of it and then share it with everybody.
How do worms form in your body?
Well, the worms, of course, don't form in your body. The worms come into your body from the environment. Most intestinal worms, I think we're talking about here, aren't we? Or other forms of worms that can get through your skin. So worms are parasites unless they're earthworms. And if we're talking about parasites that get into your guts, then usually they have different stages to their life cycle. There'll be a larval stage or an egg stage in the environment, which you then take into your body either because you eat something with the worm eggs in it, or you step on the worm eggs and they activate and come through your skin. And once they're in through your skin, they can make their way up to your lungs and then into your gut that way. In some cases, you just eat the worm eggs and they go straight through your gut and they activate in the stomach acid, hatch, and then they form worms that then take up residence in your intestine. Either way, they want to be there because that's where the food is. And there's also an exit route because they can release eggs into your feces, and those eggs then come out into the environment and they can repeat the process.
Thank you so much, Dr. Chris Smith. I love that you know a little bit about everything, but also a lot about everything. We're back together next week.